Hello again. Today we're going to continue to talk about exponential functions, and today we're going to break it down a little more specific and start looking at what's called exponential growth and decay. Those would be the two different types of results you could get from an exponential function. And this growth and decay formula that we have here is a little complicated at first, but we're going to understand it today. So first off, the A in the formula stands for your ending amount. How much do you have at the end of a certain amount of time? So again, if it's growing, that number should be bigger than what you start with. If it's decay, the number should be smaller than what you started with. Then equals P. P is the starting amount, called the initial value. How much did you have at time 0, at the beginning of your count? Then we always have the 1 in that parenthesis, and then a plus or minus. We'll talk about that in a second. And then the R. The R is the rate of growth or decay that usually comes as a percent. And we'll have to convert that percent back into decimal form, which is easy to do. You only have to move the decimal point a couple spots. That's it. And then finally, the exponent. That's what makes this exponential growth and decay. That exponent is always referring to time, usually years, but sometimes that can be months, days, weeks, hours. Just depends on the growth rate or decay rate. All right, then that parenthesis part, the 1 plus or minus r, that has a special name. That part of the problem is called the growth factor. It's always called growth factor, even if it's a decay problem, but sometimes the growth is in a negative direction. Now, that plus sign is for growth. So if we have, I'm just tired. If we have a problem that has a plus sign, that means we're looking at exponential growth. If instead it's a decay problem, then we'll be using the minus sign. We're subtracting the rate. If something's decaying, we're losing numbers, not gaining numbers. All right, so let's try some examples of what this will look like for the first part today. All right, again, all we're really doing right now is getting used to the formula. We're going to do more work with it as the week goes on. So we got this example. Y equals 3,000 times the quantity 1 plus 0.07 to the t power. So the first thing we're going to know is what's the initial value, meaning where does this start off? And that initial value is always the number in the same spot, right after the equal sign and before the parentheses, the 3,000. So that initial value would be 3,000. Now, it depends on the problem. If it's a real-world situation, that could be money, that could be the number of people infected with the disease, that could be the number of animals in a given community. It could be all kinds of different things. All right, next. What's the growth rate or the decay rate? Well, first off, is it growth or is it decay? Well, that depends on that symbol right there. If that's a plus symbol, then we're talking growth. If it's a minus symbol, we're talking decay. So we're going to go ahead with, say, growth on that one. All right, and now what's the rate? Well, the rate is this percent, 0.07, but that's the decimal version. So we're going to take that 0.07, take that decimal point and move it 2 spots, to get 7%. That's the growth rate, 7%. Then my growth factor, that's that 1 plus 0.07 part. All of those things together kind of simplified. So the growth factor, again, with the growth factor would be 1.07. All right, another example. Same basic strategy. The initial value is always in the same location, right after the equal sign. In this case, it's 550. I'm not sure what that 550 is, because it could be dollars, people, anything. Now, next, the growth or decay rate. Now, again, because this one has a minus, that makes it a decay. Now, what's the rate? Well, the rate would be this 0.035, but again, as a percent. So we have to move the decimal 2 slots to the right, in between the 3 and the 5. 3.5% decay rate in this one. And then the growth factor. That's that whole parenthesis actually simplified out. The 1 minus 0.035, that's going to get us 0.965. That's our growth factor. If that growth factor is higher than 1, we have growth. If the growth factor is lower than 1, we have decay. Let's try a couple more. All right, first thing, initial value. Once again, always in the same location, right after the equal sign and before the parentheses. Now the growth and decay rate. This one's a little bit backwards than the last one. That 1.08, that's the growth factor. That part's already done. We're going to have to work it reverse to figure out the rate. So first off, it's higher than 1, so it's growth. And then how much higher than 1 is it? Well, it's 0.08 higher than 1. That's the stuff after the 1. So I need to change that back to a percentage. That would be an 8% growth rate. Right. Last but not least, last example. Initial value. Looks like that number after the equal sign is 693. Then we're looking at, is this a growth or decay? Well, that number in the parentheses is less than 1, making this a decay problem. How much less than 1 is it? Well, you'd have to figure out how much. Well, that'd be 0.07. That's how much less than 1 that is. And again, you could always just take 1 minus 0.93 and get that. Then move that decimal 2 slots to the right. We're looking at a 7% decay rate. And the growth factor, again, in this particular problem, it's already been solved and figured out for us. They've already done that 1 minus 0.07 for us and got the 0.93. So again, they could be seen either way. You could see the growth rate like we did back in these problems where it's a 1 plus or a 1 minus, or you may just see the growth factor where that 1 plus and 1 minus has already been simplified, leaving you just with that individual number. All right, so your work today is just identifying parts from this particular formula. You're not really doing very much with these yet, but that's what the rest of the week is going to be all about. All right, good luck.